Found some
I'm
mushroom.
going to talk. Hello.
Last listen, please.
Hello.
Yes.
I'm going to talk. Some group are going to move. Then I'll talk again. How
Okay.
about that?
Sorry. Okay.
So
People should quiet now.
now, first of all, what do you observe here? You observe some mushroom that's growing on what? On a piece of log,
A
right?
piece of tree.
So the fact that it is growing on this piece of log means it is taking its. I will talk, others will move, then I will talk again. We're going to do like 3 groups, okay? So when you hear me and I finish, you can move on, then others will come closer. I said we see this mushroom is growing on a log of wood, right? It means it's able to derive its nutrient from this log of wood. Is that correct?
Yes.
It means also it's able to digest the wood and use for food, right? Now, this particular mushroom, as you see now, if you are familiar with mushroom, you know mushroom always have gills, right?
Yes, yes.
Mushroom always have gills. This does not have. If you look at this closely or you put it under the microscope, you see that they have tiny holes. They call it pores, right? They have
Pores.
tiny pores. That's where they make their spores. That's why this group of mushroom are called polypores. That's where their name comes from. They're called polypores. One more thing I need to tell you about this is that, can you see a kind of whitish mycelia growing over here?
Yes.
So that's how mycelia grow, right? Yeah, those are spores that are released and they are germinating right there. Those are the spores. Now you see that I took the cutlass and I cut into this wood. What do you observe in the wood is white. Compared to the wood you are standing on, that is a lot white, isn't it?
Yes.
Okay, why is that so? So if you remember, if you were ever thought, wood is made up of 3 major components: lignin, cellulose, and hemicellulose, right? The color of cellulose is what? White.
White.
The color of lignin is brown, right? So the combination of the lignin, cellulose, and hemicellulose gives you the amount of brownness you see in wood, right? Now this mushroom is one of the most evolved natural organisms that can degrade lignin. So as it is growing on this wood, it is degrading the lignin and the bulk of the cellulose is becoming left behind. Then because the color of cellulose is white, the wood becomes whiter. So this class of mushroom, we call them white rot fungi. Rot because they are degrading, white because they are selectively removing the lignin. Then the wood becomes whiter. Now, can anybody tell me any implication of that? As biotechnologists, what can we do with that? I just told you that the wood is made up of what? Lignin, cellulose, and hemicellulose. Cellulose is a polymer of what? Cellulose is a polymer of glucose. None of you did chemistry or biochemistry? Cellulose is a polymer of what? Glucose. What does that mean? It means if you hydrolyze cellulose, you should get what? Glucose. If you have glucose, can you do something with it?
Yes.
Yeah. You can use it for food, right?
Yes.
You can use it for fuel as well. So when you look at the biotechnological implication of this particular mushroom, it's capable of removing lignin from wood, leaving you the bulk of what? Cellulose. And if you have cellulose, you can hydrolyze it and you can have sugar. Some of you saw me pick a piece of this wood and I tasted it, I chewed it, I tasted it. If you take this white wood, grind it up and put it with 4% HCl and boil it, it becomes very sweet because the sugar is released. So there are many implications for this. This white rot fungi is able to degrade wood and convert woody biomass to what? A useful product. Now, let me take a little bit deeper. By what mechanism do they degrade the lignin? They secrete enzyme, right? They secrete enzyme. As we know, lignin is the most complex natural biopolymer on Earth. These organisms, they're able to secrete enzyme to break them down. Therefore, the enzyme must be very versatile and should be able to break down complex compounds. Is that correct? So when we have pollution in the environment, we are putting compounds that are causing problems. They are not easily degradable. Because of that capacity of white rot fungi, they can secrete that complex enzyme to degrade lignin. We are able to use this organism too to do bioremediation, because the compounds we put in the environment that are difficult, these organisms are capable of secreting the enzyme to degrade it. Their limitations are: one, they are mostly aerobic, which means they will not do well in anaerobic environment. So that's a major limitation that they have. The second thing is that they grow. As microbiologists who work with bacteria, what is the regeneration time for bacteria? How long does it take bacteria to replicate itself? 24 hours. Yeah, by 24 hours, you will not even see this thing grow on a petri dish, right? Those are the two major limitations in their application and usage. But when it comes to soil matrix, when the compound becomes more complex, only fungi are capable of degrading them. That's why they are becoming more important in environmental remediation and all kind of things, right? So let me stop there. There are so many advantages of white rot fungi. And white rot fungi is what I've studied for the past 30 years. So I know a lot about white rot fungi. I told you to read about some of my work. If you go check my literature, if anybody took that and did it, you'll see I had a lot of publications in the area of white rot fungi, enzyme produced by white rot fungi for biodegradation, bioremediation, and also conversion of biomass to different food. Okay, I think that's enough. Can this group move?